All right, we're ready to do the second half of 0.1. These are calculator examples, right? The first half was graphing linear equations. I'm recording this a little bit different, so I'm using the smartboard, and so we'll see how this works. So the first example, that number 11 says, find a window to show the complete graph of y equals f of x equals negative 0.2x cubed minus 2.2x squared plus 1.6x plus 1. Indicate the scale of the graph and give your window setting. Okay, so let's get started with that. Make sure you have a calculator and follow along in class. For the examples, I'm going to use the TI-84 a whole bunch. But you can use most graphing calculators, and I can give you a list of approved ones. Just make sure you're comfortable with your particular calculator and know how to use it. So, okay, with the TI-84, all of your graphing options are down here. We're going to hit the y equals. I already put the equation in. You guys can pause it if you want and put that in there. I actually put the next two in. We're going to use 2. Just wanted to show you something. You see how that equal sign is highlighted? As long as that's highlighted, it will graph it. So these other 2 we're going to use later on. Notice how they're not highlighted. And the way you do that is you just get on the equal sign and you hit enter. Okay, go ahead and pause that. Make sure you get that in there. Okay, I'm going to graph it. One thing to be aware of in these calculators is that when you hit graph, it will go default to the last window. And because I don't know what my last window was, I'm going to hit zoom and just go down to zoom standard so that I can make sure it goes back to the normal. This is a negative 10, 10 on the x-axis and negative 10, 10 on the y-axis. Okay, I draw it like this. It kind of looks like a parabola, but if you remember back from last year, because it's a cubic, you see the cube up there, if I subtract 1 from there, it tells me how many times the graph turns. So 3 minus 1 is 2. That means it has to turn twice. This is only turning once. That means I don't have the whole graph. So a big part of this assignment is just making sure we can play around with the calculator, adjust windows, and make them work. So let's make this work. That means down here it's either got to curve back up over here, or it's got to curve back up over on that side. So I'm going to go to Window and adjust that manually. So I'm going to go down to, I'm going to make it go lower. So go down to Y min. I'm going to go to negative 100 and see what that does. Look at the scale right there. The scale right now currently is 1. If I'm going from negative 100 to 100, I probably don't want a scale of 1. So let's change our scale to 10. Okay, hit graph and let's see what that does for us. Awesome, so that captures the other turn there. So now, instead of just seeing this part, I can see where it turns and goes back down. I can't quite see the 0 up here. Remember, zeros are the x-intercepts. So I'm going to adjust it just a little bit to the left. Again, go back to Window, go down, we're going to go to x min and change that maybe to negative 20. Let's try that. Draw the graph, and now I can see that 0. That's a pretty, I think I've got all the important parts of that graph. We can see a full graph of that. Now it says to either give we want to draw a picture of it up here. It says either to give our scale or to give our window setting. I'm just going to write down the window setting. So we have the x-axis, right, and it went from negative 20 to 10. And then I have the y-axis, and it went from negative 100 to 10. Once I've got that in there, I'm just going to draw a quick sketch of what it looks like. Since I have the scale there, it comes in like this, goes up just a little bit above right there, and then heads back down that direction. You could also draw the dashes up here and draw the, if you want to just draw this and label it, if you want to draw the scale on there. Hey, example 12 says find the zeros. To find zeros, we're going to go back to the calculate menu. So we're going to go second calc. And that gives you a bunch of options there. It has value, 0, min, max, intersect. We're going to use all of these. Those numbers 6 and 7 are calculus options. But for now, we're just going to find the zeros. Go down to 0, hit enter. And you have to answer the questions. So there are 3 zeros. It will only find one at a time. So the first question says the left bound. I'm going to start this one on the far left. So I got to scroll over to tell it where to start looking. So I'm going to keep going. Right there, I'm almost on it. If I keep going, I'm definitely to the left now. I'm going to go one more time. It goes off the screen, but I know I'm to the left. And as I hit enter, you'll see it draw that line and that arrow. That's where it's going to start looking. Then I'm going to scroll back to the right. It says right bound. Make sure I'm on the right side of where it crosses, hit enter, and you'll see those two little arrows pointed. Your 0 has to be between there or it won't find one. And then it says to guess. Just get as close as you can to where it crosses, hit enter. In calculus, in AP Calculus, we always go 3 decimal places. So that would be, the 0 would be negative 11.649. And you can either truncate it or you can round it. Hey, down here, notice if you have a 0, it's the x-intercept, the y-coordinate should be 0. Don't let this bother you. It says 6e to the negative 12. That e to the negative 12 means move the decimal 12 places to the left. So it means it's 0.000000, 11 zeros, 6. So it's essentially 0. The calculator doesn't find the exact 0, but I mean it's accurate up to what's that, 12 decimal places. So just round that off to 0, don't worry about the y. We need to find, there's 2 more up here. They're kind of hard to see because we zoomed out. Here's a quick trick. If you hit zoom, go to zoom box, we can actually zoom in on the part we want. So go to where you want your box to start, hit enter once, and then if you scroll over and up or down, it forms a box, and then it will zoom in just on that area. So you can kind of select what you want to zoom in on. So I hit enter. Okay, now I can see them really good. So I'm going to use that calculate menu again, second calc, 0, answer the questions, left bound. I'm going to find this one on the left first, so get to the left of it, enter, right bound, enter, guess, enter. Okay, so the second 0, notice in this one it did round it off to y equals 0, but the x, the 0 is negative 0.406. Hey, go ahead and pause this and you guys find that last one. Find this one over here on the right just to practice and make sure you know how to do it. Example number 13 says find the points of intersection of y equals negative x cubed plus 12x squared plus 9x minus 3 and 3x plus minus y equals plus 5 equals 0. Just be careful. To put it in the calculator, it has to be in the y equals form. That one is, so we're good there, right? That one's in the y equals form. This one is not, so I need to solve for y. So I'm going to minus the 3x over to that side, and minus the 5 over to that side. So I end up with negative y equals negative 3x minus 5. Okay, divide everything by negative 1. I end up with y equals 3x plus 5. So I want to graph that equation and find their intersections. Okay, let's go ahead and do that. So I cheated and I already have mine in there. If you want to pause this, you can enter them in. Make sure the equal signs are turned on like that. I'm just going to graph those two. Okay, I'm going to go back to that calculate menu. This time I'm going to go down to intersect. It's going to draw the graphs. Notice that first function is a cubic again. That means it can't change directions only once. It's going to change directions twice. By the way, the rule on that is it's 1 less, so that's 2 times, 2 turning points, or it could go down from 2 from there. So it's possible it could have 0 turning points. But because we already know this one has 1 turning point, it has to have another one. So I'm gonna go up higher because I need to find the other place where it changes directions because there might be another intersection. So I'm gonna go to window. Oh, you know what? It's still going to that old window. Let's first go to zoom standard. Okay, so there's our graph. There's the first function, there's the second. We still can't see the rest of the cubic. So let's go back into window. We need to go lots higher to see if we can find out what happens. Let's go up to 100. Again, we'll go by tens. Regraph it. So it's going up. It still goes off the screen. Let's see if we need to go to the right a little bit. Let's go to window. Let's actually go up to 200 for the max. And then for the X max, let's go like 20. Let's go over to the right a little bit. Try it one more time. Okay, we don't quite catch the top of the curve there, but we can see where it comes back down. And now my points of intersections are going to be there, there, and there. So we've got 3 of them. To find them, you go back to second calc. This time we go down to intersect. And you still have to answer the questions, but they're different questions. It says first curve, and it's kind of hard to see, but up at the top here, The first curve, it lists that first function we put in, the negative x cubed plus 12x. So we just hit enter on that. We want to find the intersection of the first graph. Second curve shows that y equals 3x plus 5. That's the other one we want to find the intersection of, so hit enter again. And then it says to guess. It will always find the one you're closest to. So right now, it would find this one. If I scrolled over here, it would find that intersection. If I scrolled back, I'm going to start with the one on the far left. So I'm going to scroll all the way back to here, hit enter. Okay, there's my first intersection. Let me write this down. It is at, and go 3 decimal places, negative 1.046 and 1.861. Okay, you guys pause it, practice finding those other 2 intersections. The key thing to remember is you have to select the first curve, the second curve, the first equation, the second equation, and then you'll always find the one you're closest to. So you'll have to scroll until you get closest to the intersection you want to find. Hey, one really valuable thing, we're going to use these calculators for a lot, is to solve inequalities and equations. So this last example, number 14, says use a calculator to solve. The absolute value of x squared minus 5 is greater than or equal to 4. Okay, write your answer in both inequality notation and interval notation. So let's go through this. What we're going to do is we're going to take that 4 and move it over. So we're going to have the absolute value of x squared minus 5 minus 4. Make sure the minus 4 is still on the outside of the inequality, is greater than or equal to 0. And then we're going to take this part and graph it in our calculator. So we're going to graph y equals the absolute value of x squared minus 5 minus 4. What we want to find out is when is this graph greater than 0? And I'm only looking at the x coordinates, right? I'm trying to solve for x up here. So go ahead and go in your calculator, go down to y equals, I'm going to clear these out. If you just hit clear right there, it'll clear out the entire equation. To get to the absolute value, you hit this math key right here, so math, and you go over to number, and there's it says abs, right? Not talking about your 6-pack, it's talking about the absolute value. So hit enter on absolute value, should bring up those. Enter in x squared minus 5 minus 4. Okay, go ahead and hit, and I'm going to change the zoom standard. Remember, you got to do that or it will default to that last window, which we changed a lot on that. Okay, here comes the first one. Oh, here comes the graph, there's only one. Okay, I want to find out when the graph is greater than 0. Well, if you look at it, think about when is it above the x-axis? When is it greater than 0? So that would be at that point to the left, between those two, and then from that point to the right. So we need to find that. So let's find the points where it actually equals 0, and then we can set up our answer. So we're going to go, again, second calc. Those are the zeros. Right, just like before I answer the question, left bound. Doesn't matter how far, just make sure you're to the left. Right bound, just get to the right. Guess. And it says the zero's at -3. So I'm going to think of kind of like a number line here. We know there's on the x-axis there's a 0 at -3. Okay, let's find the other one. Second calc, 0. Get to the left of that one, enter, right, enter, guess, -1. We could find the others. This graph actually is symmetric, so the other one's going to be at 1, and the other one's going to be at 3. Those are my 4 zeros. Now notice we want to find out when it's greater than 0. So when is it above the x-axis? So that would be to the left over here. So everywhere that direction, whenever x is greater than that, the graph is above. Also, everywhere between those 2 points it also is. So between -1 and 1. And then everything to the right above 3. That's kind of what the graph will look like. If you want to put dots, that'd be a closed dot, closed dot. Closed dot means it equals that, or if you remember, you can do these brackets. Brackets means that it can equal, and the reason why it can equal those points is because of the equal sign right there. Okay, right, it says right with the inequality notation and with interval notation. Inequality notation, describe that, we would say x is less than or equal to -3, or x could be between -1 and 1. So this is how you write that. Or x could be greater than or equal to 3. So there's our inequality notation. That's the way we'd write it. Interval notation, you guys have done this before, but just a reminder, you start from the left, it goes to -infinity. It goes until you get to -3. Then you do this. This just means or, which means it includes them both. It also includes from -1 to 1. And it also includes 3 to infinity. Okay, if you go back up here, so that's our answer right there at the interval notation. As a side note, let's say this had been an equal sign. We'll do this a lot. You'll have to solve an equation rather than an inequality. Then our answer would have just been, when does it equal 0? So the answer would have just been -3, -1, 1, and 3. So you can use a graphing calculator many times when you can't solve by hand. You can use it to solve an inequality or an equation that we can't do algebraically, but we can do using the calculator. Okay, make sure you're really familiar with it. We're going to use the calculator a lot. Half of your AP test is you get to use a calculator, and on a lot of problems you have to use a calculator. So it's not an option of we want you to, it's that you need to know how to do some different things with that. Thanks.